Professor of VC at Institute of Aeronautical Engineering, Hyderabad. Today we are discussing about algorithm performance analysis and design and analysis of algorithms. Design and analysis of algorithms. So algorithms analysis, analysis of the resource usage of a given algorithm in terms of the time and space, etc. But the efficient algorithms. So algorithms that make an efficient usage of resources. Algorithm design. Here methods for designing efficient algorithms. So these are the major tasks while you are using the design and analysis of algorithm. Okay. Next, algos, Greek word for pain because of the background of algorithm. So algos, the Latin word for to be cold. Why study this subject like design and analysis of algorithms? So efficient algorithms leads to efficient programs. Okay. So once we are having that efficient programming, so we can change throughout the globe. Yeah, efficient programs sell better. Yeah, efficient programs make better use of hardware. So we will expect your desirable. And programmers like me and you who write efficient programs are preferred. Okay, so what are the objectives? It's to gain experiences in fundamental techniques used for algorithm analysis and the main methodologies used for the design of efficient algorithms. Next, to study the most important computer algorithms of current practical use. This is the major objectives. So what is the algorithm? We know that algorithm, where algorithm is nothing but the word algorithm came from the name of the Persian mathematician. So Abul Jafar Muhammad ibn Musa a Coheligium belongs to what you call ninth century. Okay, an algorithm is simply a set of rules used to perform some calculations, either by hand or more usually on the machine, like manual operation and practical operations. Simply a set to be a set of rules used to perform some calculations either by manual operation or practical operation. Manual operation may be by hand or practical operation usually on the machine, like this one, the computer. Okay, so definition: an algorithm is a finite set of instructions that accomplishes a particular task. So another definition is a sequence of the unambiguous instructions for solving the problem. That is okay, for obtaining the required output for any legitimate or genuine input in a finite amount of time. Okay. In addition, all algorithms must satisfy the following the criteria, like characteristics. Okay. So maybe here the one is the input. Zero or more quantities are extremely supplied as input. Okay. Consider Fibonacci numbers program. Here aim of the problem is to display 10 or 9 or according to our task Fibonacci numbers. So no input is required. The problem itself, this is the clearly mentioned as a 10 by using this all Fibonacci numbers. You can consider Fibonacci numbers are program. Yeah, so aim of the problem is to display the 10. Based on that, without this all input, we will expect in the program. Okay, the problem itself, this is clearly mentioned as 10. Okay, Fibonacci values, so 0 items required for input. Okay, another problem is displaying the given numbers of events So user should accept how. Okay, like many events requires based on the user input, the number of events is to be displayed. So one data, okay, item is required as input. Okay, like this we are ready to define that algorithm with just examples for understanding. Okay, second one, so output. At least one quantity is produced by given algorithm as output. Okay, in the case of Fibonacci numbers program, after executing the program, first 10 Fibonacci values displayed as a output. Okay, in the second case, based on user input, it should be display given number of events, or maybe odd, or maybe an input of negative number is wrong. Should display the proper error message as output. So this is the program. Okay, so this program displays at least one output as a error message, or we can consider, or we observe number of in outputs that show the given number of what you call steps. So like this, that algorithm is involved this values, and what is the and what you call definiteness. Each instruction is clear and unambiguous. That is, each step must be easy to understand and convey only a single meaning. Like next one, effectiveness. Each instruction must be very basic so that it can be carried out by a person using only pencil or paper. Okay, so this effectiveness, and these steps is common in both the Fibonacci and the primes. Okay, here. So for example, if a user enters a negative, say for example, so negative numbers as input in events. If we have a step like what do you call step if n less than 0, capital N less than 0. Okay, so this capital N less than 0, okay, less than 0, then what happens? Okay, go to error. Next, wrong instructions given as to go to error. Okay, like this effectiveness. So I have to verify using this step is common in both Fibonacci and prime numbers. Okay, those kinds of instructions should not be there in an algorithm. Okay, so next step is finiteness. If we can trace out the instructions of an algorithm, then for all cases, so the algorithm terminates after a finite number of steps. Either in the case of Fibonacci or even numbers, problem should be solved in some number. Okay, like this, the fitness, what you call fineness, finiteness. So if we can trace out the instructions of an algorithm, so should be solved in some number of steps. Say for example, continuous display or Fibonacci series with without termination leads. So to abnormal termination. So this is the major criteria for algorithm. Input is what you call 0 or more inputs. Output is at least one output. Fitness is n number of steps. Okay. Definiteness, clear algorithm step. The effectiveness, a carried out step. Okay. Now, in particular algorithm, so we can ready to analyze the process of design and analysis of algorithms. Okay, like you can consider the process for design and analysis of algorithms. Okay, so first one is understand the problem. This is the very crucial phase. If you did any mistakes in this particular step, okay, the entire algorithm becomes wrong. So before designing an algorithm is to understand the problem first, and second one is solution as an algorithm. Problem is ready. Okay, and we have to understand the problem. After that, we dig on that solution. That's why we go for the second step, the solution as an algorithm, exact versus approximation solving. Solve the problem exactly if possible. Even though some problems are solvable by exact method, but they are not false. So when compared to approximation method, so in that situation, we will use approximation method. This is a solution as an algorithm. You can consider exact versus approximation solving. Yeah, coming to the next algorithm techniques. In this, we will use different design techniques like divide and conquer and greedy method. The third one is dynamic programming. Fourth one is backtracking. Okay. Fifth one is branch and bound, etc. Okay. So here, fourth one is prove the correctness. Once algorithm has been specified, next we have to prove its the correctness. Usually, testing is used for providing correctness. Yeah, if it is permitted, testing. Okay, testing is used for providing what you call correctness. Okay, so fifth one is analyze an algorithm. Analyzing an algorithm means studying the algorithm behavior. So that is calculating the time complexity and space complexity. So like this, we are right to analyze the algorithm. Analyzing the algorithm means studying the algorithm behavior. That is calculating the time complexity and the space complexity. If the time complexity of algorithm is more, then we will use one more designing technique such that time complexity should be what do you call so minimum. Like this, we have to observe the analyze and the algorithm. The next one is coding an algorithm. After completion of all phases successfully, then we will code an algorithm. Okay, once it is all completion of the all phases successfully, so you go for that. Coding should not depend on any program language. Okay, we will use general notations. Okay, the notations maybe you can consider. Next one is pseudocode and English language statement. Okay, so ultimately algorithms are implemented as computer programs. We know that how we are implementing the algorithm step by step process and so on with the help of manual operation is not that much accurate. If you are using the practical operation like using computer program, we will expect our desirable. Okay, next prove that correctness. Once algorithm has been specified, next we have to prove its correctness. This is the way analyze an algorithm. After that, you go for that what you call coding an algorithm. Finally, you will use that general notation. After that, ultimately programs are implemented as computer programs. Like what is the pseudocode? Okay, so most of the algorithms are presented using the pseudocode. Okay, since they can be read and understood using programmers. Okay, who are familiar with the different programming languages. All are becoming programmers. So once we are becoming a programmer, once we are familiar with the number of programs within our hand, we are all becoming a software engineers. Some programming constructs used for the pseudocode, like the code is pseudocode is belongs to read, print, set, initialize, increment, if then and if then else, and if. So what you call repeat, until, do, while, etc. This is some programming constructs used for the pseudocode, like this from read to up to do, while, etc. These are the we are considering the pseudocode background, how their people are using the read and understanding using the programmers, okay, who are familiar with the different programming languages like C and C++ and Java, including Python. Some programming constructs used for the pseudocode like read, print, set, initialize, increment, if then and if then else if, repeat, until, do while, etc. What is the difference between algorithm and pseudocode? Here, an algorithm is a well-defined sequence of steps that provides a solution for a given problem, while pseudocode is one of the methods that can be used to represent a algorithm. Okay, this we can consider this the methodology or maybe method. So while programmers or maybe while algorithms can be written in the natural language, so pseudocode is written in a format that is closely related to high level programming language structures. Okay, but pseudocode does not use specific programming language syntax and therefore could be understood by programmers who are familiar with the different programming languages. Okay, so additionally, what do you call transforming an algorithm presented in a pseudocode to what do you call programming code could be much easier than converting an what do you call so algorithm written in natural language. Okay, so next one, one distinguish between that the difference between the algorithm and pseudocode. An algorithm is a well-defined sequence of the steps that provides a solution for a given problem. So while pseudocode is one of the method that can be used to represent a algorithm. So while algorithm can be written in the natural language like this, finally, what you call algorithm written in natural language. So after that, we'll try to verify that performance analysis of algorithm. Okay. So before that, before entering that all performance of algorithm analysis of algorithm, so already we have seen that algorithm we know, but we don't know that all program. Yeah, we have to consider that what is programming. Okay. So here, programming is to represent data and data structures. Okay, solve the problem using the data. Okay, so we can consider this all are what you call in terms of algorithm. Okay, so here what is the definition of this data structure? Because of we are using that all data structures, no, program used to represent the data. Okay, and data structures solve the problem using data. The time we require that all algorithms. After that, once we write that all algorithm, of that should write the programming. Here data structures, primitive and non-primitive. Basically, we have the two types. Major things are primitive and non-primitive. Integer, float, character, and non-primitive, linear, non-linear files. And click on this linear. There is a arrays list. Click on this list. It is split the stacks and queues. So non-linear, what do you call non-primitive under non-linear here is trees and graphs. This is the structure data structure classification. So based on this, right, to define that data structure. It is a way of collecting and organizing data in a computer. Then aggregation of what you call atomic and composite data into a set with a defined relationship. Okay, so after that, once we know this data structure, after that, what is the algorithm? Definition and finite set of instructions. Already we have seen that algorithm in terms of what we call manual operation or practical operation. But this case, in terms of the data structures, how it is affect the algorithm. A finite set of instructions that should satisfy the following. So input zero or more inputs, output at least one output. Okay, defined as clear and ambiguous instructions. We have seen what you call finiteness and terminating after the finite number of steps. Okay, effectiveness like mission executable enough to be carried out. Okay, and we have seen in depth of this order, but it is a summarize that algorithm. In computational theory, algorithm and programs are different. Programs does not satisfy, okay, like what do you call that OS. Algorithm, what are the algorithm specifications? How to express the algorithm? Algorithm, step by step method we are following. So what type of specifications are involved in particular algorithm? How to express the algorithms? High level description and natural language and graphical representation, like best example is the flowchart. After that, the pseudocode. Okay, informal language dependent description. So implementation description. Okay, and C by using the C or C++, Java, etc. Okay, this natural language is a graphical chart. Here, place in text in the short list. Here it is selection sort. From those integers that are correctly unsorted, find the smallest value. Place it is next in the sorted list. Okay, but here it is list 0. Okay, list 1. We are having that list 0, 6, 2, 2, and so on. List 1, 5, 5, 3, 3, 3, and so on. Here it is, what do you call? List 2, 3. Okay, like 3, 3, 5, and like this. List 3, list 5, 4, and so on. So step 1, it is followed that one from those integers that are currently unsorted. Find the smallest value place in it next in the sorted list. Okay, like this. So this one is sixth. When compared to this and this, which one is the shortest? Here it is first one 2, then next this one 6, and so on. Like this, compare these two. Okay, like this, easily right to sort, and this one, and finally. So we should follow this step 1, step 2, step 3, step 4, 5, and 6, and so on. Okay, so selection sort. Yeah, we should write that all piece of code is a piece, so what you call pseudo code, like a C language. C for I equal to 0, semicolon, I less than n colon, semicolon, I plus plus, with the parenthesis open. Examine, here it is, using this particular code. Okay, examine the numbers in list. Okay, list I to list n minus 1. Suppose that the smallest integer is list minimum, what you call interchange list I and the list minimum. So the parenthesis, that is semicolon, is call braces is closed. So this is the selection sort. Okay, next selection sort with help of this. So void sort, what you call int space list. Okay, square bracket open and close, comma int of n with curl braces open, int I comma j comma minimum semicolon for I equal to 0, semicolon I less than n minus 1, semicolon I increment I plus plus parenthesis open. So minimum is equal to 1 for j equal to 1 plus 1, and j less than n, semicolon with j increment if list of j less than list of minimum. So minimum is equal to j semicolon. Swap this list I list minimum semicolon. So the call basis is here it is open now. This is now it is open and close. Here also open and close. So like this selection sort, we have to develop this particular code. Implementing the C code, we will expect our sorting. Okay, like how do we evaluate the algorithms? Does the algorithm use this what you call storage efficiently? Like this, using this all parameter, algorithm analysis will be appeared. Okay, is the running time of the algorithm acceptable for the task as per the previous code or pseudo code? Okay, so performance analysis estimate the mission dependent independent time and space. You know that is space complexity, time complexity. So within this, So use this simple code void search int of array. So int length, int target for I equal to, what do you call, here it is, I equal to 0 and I less than length, I increment. If array of I, so target return I semicolon, so return minus 1. So performance analysis here, estimate the mission independent time and space. Space complexity and the amount of the memory needed. Time complexity, amount of time taken for an algorithm to finish. Like this, algorithm analysis is depending upon how do we evaluate the algorithms. Like the algorithm use the storage efficiently. Is the running time of the algorithm acceptable for the task with the help of this piece of code? Performance analysis, it is depending upon estimating the mission independent time and space complexity, and amount of memory needed, time complexity, and amount of the time taken for the algorithm to finish. Okay, so like this, what are the space complexity? So what are the definition of this, background of the space complexity? Okay, so here it is, mission independent space required by an algorithm. Okay, so like a best example, you can consider the piece of code. Okay, enter ABC of int A, int B, and int C. Okay, so that's a curly brace is open. Return A plus B plus B into C plus 4 comma 0. Okay, 4 dot 4.0 semicolon. So the curly brace is closed. Now the character char given memory int n, character P, so return P, so on with this. Okay, so what is the better for the space complexity? With the help of the simple code, okay, like here's float the sum, float list int n, float temporary sum equal to 0 for int I equal to 0, I less than n semicolon I increment. Okay, temporary sum list and return like this. Okay, it's like floats or some float list and so on. With this, so based on this, the time complexity, where mission independent time required by the algorithm. Okay, time is not easy to estimate. Okay, so with this alternative, like count the number of program steps instead of the time. Say for example, 10 additions, 10 subtractions, 10 multiplications, it will take that 30 steps. Yeah, say for example, you consider any piece of code like this here, 10 additions, 10 subtractions, 10 multiplication, 10 CA plus 10 CS, 10 CM. CA means additions, 10 CS means subtractions, 10 CM is multiplications, where C is the time for one addition, CS is time for one subtraction, CM time for one multiplication. With this, easily time is not easy to estimate. Somewhat it is critical. Okay, alternative count, where I to use that one. Time complexity program steps, it is somewhat, it is depending upon steps, program steps, syntactically or semantically meaningful program segment whose execution time is independent of the number of inputs. Any one basic operation, maybe one step, we have to use that plus, minus, calculation, backslash, assignment, jump, comparison, etc. Any combination of basic operations, one step, like using the plus equal to then to backslash and a plus c multiplication d and etc. and so on. Okay, so for example, using this all above, what you call this program steps, using any basic operations, a combination of any combination of basic operations, how based on this program, best example you can try to decide. Int ABC of int A, comma int B, int C, curl brace is open, return a plus b into c plus 4.0 semicolon, and so on. So by using this solve directly, we are right to estimate how many operations are required, how it is, how much time is involved with using the C or C plus plus Java, Python. Okay, this is relevant to the program. Okay, so what is the better for the time complexity? So here it is using this the same code with the one use how many piece of codes are available, how many functions are available, and like this right to decide the factor. Okay, like this the time complex up to time complexity. So what is the major observation? It is relevant to the algorithm. If you are ready to implement the accuracy algorithm or not, you will try to decide. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.